how long the class will be. It will be around 90 minutes, but if you guys have questions, it might become 2 or 2.5 hours. Usually I aim to do it in 90 minutes, but many times there are many questions and we review them together. Okay, we have a wave of people, so I think we will wait another 5 minutes and then we will start. And either way, if you can't attend the entire class, I'm going to record it anyway and I'm going to upload it right after this, so you will be able to rewatch it and check everything out. And maybe it's a good idea that if you have any specific question that you find a bit hard while you study and you want me maybe to solve it together, you can send me a screenshot on WhatsApp and I will review it over the class so we can solve them together as well. Can we message you on WhatsApp? Yes, feel free. If you don't have my number but you want to send me specific questions, my number is this. And just send me a picture of the questions, and while we solve questions together, when I give a few minutes to solve each question that we are going to do today, I will review the questions myself and I will show the best questions. Or maybe similar questions as well. Hey Ari, should we expect a higher level exam this year? It's really hard to say. The thing is, the test di medicina, which was yesterday, was harder than usual in the chemistry, but usually they are not associated. So if the test di medicina is harder, the IMAT, it's varies a lot. It's never set in stone. So for example, the 2017 exam was really difficult, but the next year was way easier. So it varies a lot, and the scores are going to change according to the difficulty of the exam. So even if it's going to be a difficult exam, it's going to be more difficult to everyone. So you need to take it into consideration when you maybe feel a bit stressed after the exam because it was a bit difficult for you. It was difficult for everyone. So I wouldn't stress about it. Guys, can you hear me well, or should I increase the volume a bit? Perfect, thank you. I think we should start. We have a lot of questions to do. So sorry guys, I wasn't available on Telegram since the past 4 days. It's fine, Manish, don't worry. Thank you so much for your work. And thanking one of the volunteers. Everything you see, this free class and many classes I did also another class 2 days ago. I'm able to doing these classes thanks to the volunteers we have on Med School. And every year, last year for example, we had 2 volunteers. It was me and 2 people, and this year we reached 50 volunteers. And this is why we were able to publish so many free study materials for you guys. So I'm really proud of it, and I really hope we were able to actually help you in the process to actually study for the exam. I'm well aware how difficult it is to focus on the specific topics for the IMAT exam, and especially in the last few days before the exam, it's very easy to just get overwhelmed by the amount of study material you might want to review. So I hope after this class I will actually be able to help you to know what you should focus in the next couple of days, as well as a couple of steps and an exam strategy I highly suggest to follow when you approach the IMAT exam. Something I saw with many of my students in August and last year as well is that they are not 100% sure which steps they are going to follow when they actually approach the exam. Many of them try to solve the exam from question number 1 all the way to 60, and they don't have a very specific strategy as well when it comes to the sequence of questions they are going to solve, and especially the sequence of steps they are going to use when they actually solve each question. So basically what I did today is I took the hardest questions from around 3,000 questions I analyzed. So don't be a bit overwhelmed or demotivated if some of the questions are very difficult for you. I took them because they are very difficult and challenging. And we're basically going to analyze the questions together, and we're going to break them down step by step, and I'm going to show you guys how I actually approach these kind of questions. Each questions that I brought today basically represents at least one trick Cambridge always do on the IMAT exam, and knowing these tips is extremely crucial, especially when it comes to the steps you're going to follow on the IMAT exam and how you recognize these tips. So I think we should start. I will share my screen with you guys. Let me know if you can see it. Partly. We will increase it a bit. Is it okay, guys? Can you see my screen? Yes? Perfect. So before we start, I would like to know if any one of you actually watched the marathon we did last year. I uploaded the recording to my personal YouTube channel, so let me know if you actually did. If you don't, if you go to YouTube and search for Enter Med School IMAT Marathon, there is a 12 hours recording that we did last year, and there are many parts of it that I highly suggest to watch specifically if you don't have the 12 hours to watch. Shalev my roommate did a 2.5 class for the logic section. It's extremely efficient because he's dealing with the logic questions and logical reasoning for around 4 years now. He is also a native speaker and he really dealing with it, so he made a class 2.5 hours, which is very, very important to watch. And I would also like to know if you have any experience with the website, my Enter Med School, solving logic questions, or the pocket trainer we had last year, or in general, how you guys actually solve and prepare for the IMAT exam so far. So what did you manage to actually solve, and how many questions did you practice, and when you actually solve these questions, did you actually apply any sort of strategy? Or do you guys want me to show you as well today to how I actually solve each and every question? So just the critical thinking part, okay, of the marathon, yeah, it was very good. Okay, I see many people that watched the marathon, that's really good. If you didn't, I highly suggest to follow, there is time steps in the description, just watch the critical thinking, it can give you some tips to how to solve them. So it's really good. So last year, what I did is I took all of the questions of the IMAT exam, BMAT exam, as well as the IB, which is it's an exam that's being conducted by Cambridge as well every year. And many people don't know about the IB. If you go to ibdocuments.com, you basically have all of the past papers of biology, chemistry, math, and physics of the IB exam, which is the high school exam Cambridge conducts in the UK. It's a very good source to practice extra questions in the next couple of days. So I highly suggest to check it out. And what I did is I took the hardest questions from all of these papers, and I'm going to show you guys how I actually solve them myself. I'm going to give you a couple of minutes to solve each one. And then on top of it, I would like to hear from you if you have any questions that you want me to elaborate to find any weak spots, because this is what I do usually with my students one-on-one. I show them the question, and this way we can actually dig in the study material and find specific weak spots you should basically study before, a few days before the exam. So when it comes to critical thinking, last year we showed that the vast majority of the questions are conclusion, assumptions, and arguments. The thing is, because you are a couple of days before the exam, I highly suggest when you practice critical thinking questions to focus on the questions, the type of questions that are very likely to appear on the exam, which means on Enter Med School you can pretty much find close to 600 logic questions taken from the TSA, which is another exam, a bit more difficult than the logic section of the IMAT. So 600 questions, it's pretty difficult to solve a few days before the exam, and it's not very smart because you want to focus on other things. What I would do is I would basically focus on the questions that have more probability to basically appear on the exam. When it comes to biology, when it comes to metabolism, for example, they usually, in the first semester of medical school, what they do is basically they teach you biochemistry, and you need to know all of the metabolic pathways. And if you read the syllabus of the IMAT, it's pretty much very similar. They are not very specific when it comes to what you need to know when it comes to biochemistry. But after analyzing so many questions, I realized if you really want to know what to practice for biochemistry, it's mainly the metabolism of glucose, and it means not the enzymes of glycolysis, of the Krebs cycle, and the names, and you only need to know basically the products of each metabolic pathway: glycolysis, link reaction, Krebs cycle, and electron transport chain, and what happens in different cells when it comes to aerobic and anaerobic respiration. It's something that we will go through today, and you will see in around 10-15 minutes that you can actually understand and memorize very specific numbers and basically cover the entire section for metabolism. Central dogma, they also have a question every year where they give you a sequence of either coding DNA, template DNA, mRNA, tRNA, and they want you to complete the strand either to the complementary strand or a few steps after it. There is a very specific set of basically tricks. They always try to trick the aspirants that take the IMAT exam. So I will show you basically an example for a question which covers all of the tricks that they can do on the IMAT exam when it comes to the central dogma. Cell biology, it's mainly memorizing the function, the name of the organelles, and it's so important the differences between animal cell, plant cell, yeast cell, and prokaryotic cell, what you do have inside and what you don't have inside. They don't really go in details, for example, the chemical reaction that occur inside the Golgi or the Raphael. They never ask on it. What they do ask is the general concept of what you have and don't have inside the different organelles and the different basically cells. It's so important to memorize. There are some tables on Enter Med School, and if you want, guys, I can send you another table on the WhatsApp group or Telegram group. Just remind me, even on Enter Med School, that basically shows what you have in each one, and you basically, if you memorize this table, you're good to go. So just give me a reminder after this session, and I will send it on Enter Med School. Genetic mitosis and meiosis, there isn't a year that you don't have a genetic pedigree or mitosis-meiosis question. Usually it's both. But when it comes to actually analyzing genetic pedigrees, there is a very specific set of tricks you should follow. For example, if both of the parents are healthy, but one of the kids is sick, so it's for sure a recessive disease, and for sure the parents are carriers. All of these sort of tricks that if you memorize them, it's very easy to recognize the template inside the genetic pedigree. So what I would do, I would try to go to Enter Med School to the latest simulator. I uploaded the question on the genetic pedigree. I wrote a question on the genetic pedigree. And in the work solution I uploaded, I basically explain all the different scenarios that very likely to appear on the exam. So you have like a 2-page summary I wrote for you guys where you can actually understand which type of tricks and templates you should follow when it comes to the genetic pedigrees. Mitosis, meiosis, it's mainly counting the number of chromosomes, centromeres, and DNA molecules, and differentiating between the very complex and confusing definitions like chromosome, centromere, centrosome, centriole, all of these very similar names. The Cambridge know you're most likely going to confuse a bit between the definitions because it's a very stressful exam. So they on purpose writing the questions to confuse you when it comes to the very similar definitions. What I suggest is to basically create a table of the very similar definitions when it comes to mitosis and meiosis and make sure you know them exactly. And if you want, guys, of course, after the session, I can send you some extra resources and the things I use, of course, when I study for my own exam. I just need to dig in my Anki deck and stuff. Biotechnology, it's mainly three things. They never expect you to actually know the name of the enzymes and the machines you use in the lab. What they do expect you to know is the sequence of what you actually do in the lab. For example, if I'm going to split biotechnology into the highest yield point you should memorize, I would focus on PCR, gel electrophoresis, and gram staining of bacteria. Do you guys recognize all of these definitions? PCR, gel electrophoresis, and gram staining? No? Yes? Okay, so it's 50-50. Okay. So PCR we all know from COVID, basically. It's a test. It's not a test, but it's more of a way to amplify the DNA molecules. So what we do, we take several DNA molecules, and using a specific set of enzyme, we basically replicate them over and over and over and over again, and it's an exponential growth. So each round of PCR is going to give you basically the power of 2 of the number of the molecules you had to begin with. So you reach a point where you have a single strand of DNA that you want to investigate, but you have billions of it, therefore you're going to be able to actually find it in the lab and then say, okay, this person has COVID or not. So I can send you a video after this class. It's a 5-minute video. It's a very good video. It's PCR, it's mainly 3 steps. It's the breakdown, you basically heat up and cool down. But because I want to basically review a lot of questions today, and I know many people study with YouTube, so I'm basically going to create a list for you guys of YouTube videos. Just let me know which one you want about specific topics that we study together today. And it's a video basically that's going to explain it way better than what I can, and this way we are going to actually cover way more topics. So this is for PCR. Gel electrophoresis is a way in the lab that you basically check the weight of different DNA molecules, and it's a very easy way to remember, so I'm going to send you a YouTube video that explains it as well. And gram staining is a way to differentiate between gram-positive and gram-negative bacteria. So you have different bacteria, and different bacteria have a specific basically thickness of the cell wall. If the cell wall is very big, it's a gram-positive bacteria, and if it's very thin, it will be gram-negative bacteria. In the lab, basically, you have a way to actually stain the bacteria with basically color, wash them, and see if some sort of coloring actually stays inside the bacteria or go out of the bacteria because the cell wall is basically thin enough to wash out the color. I will also send you guys a very good video on it as well after the class today. So if I say any definition that you don't recognize, tell me in the chat and I will write it down on the PDF I'm using right now. So I will be able to, after this session, I will write a post on Enter Med School basically that summarize this class up, and I will also link the recording of this session as well. So PCR, gel electrophoresis, and gram staining of bacteria. Wait, I have to turn on my fan before I'm melting. Okay, great. Physiology anatomy is completely different than the testa medicina. The thing is that the anatomy of the testa medicina, the Italian equivalent basically, is way more complex than the anatomy of the IMAT exam. I never saw any questions on anatomy except basically asking you the different positions of the GI in relation to the thorax or something, and that's it. So anatomy is not a very big part of the exam. However, physiology is one of the biggest, basically it's medicine, so they expect you to study it in a lot of detail. The thing is, because I analyzed a lot of questions, I basically made a list of the most probable topics to actually appear on the exam. And if a couple of days before the exam I would prioritize what I should review first in physiology, it would be basically a must action potential and muscle contraction. So these two are extremely important, and almost every year you have a question on action potential in the nervous course. So action potential and muscle contraction. Very sorry for my very bad handwriting, so I hope you understand it. After it, I basically, when I study perfectly action potential and muscle contraction, I would study the GI. Basically, in the GI, you need to know the names of the enzymes, the places, the cells that secrete these enzymes, and where you basically break down lipids, carbohydrates, proteins, and nucleic acids, the places in the mouth, in the stomach, in the duodenum, etc. And when it comes to the nephron, it's basically all the filtration, secretion, absorption, the different places, the names of the parts of the nephron, and of course the absorption of water with ADH, which is extremely important, so the mechanism of ADH as well. After it, last year, many of you, I'm sure how many of you actually managed to solve the IMAT 2020, which was the last one? You did? Okay. You as well? Okay, so many of you noticed that there was a very weak questions in the metabolic pathway of the eye, with the rods, with the rhodopsin and the retinal. It was a very weak questions, but it was once in the entire 9 or 10 exams we had so far. So this is the lowest priority topic I would prioritize when it comes to physiology, especially because it was already last year. I would maybe not study the eye. However, they might surprise and ask either on the ear or the taste and smell. So I would give it a try to understand, not in very details the biochemical pathways, but maybe the sequence you have in the outer, middle, and inner ear, for example, or maybe just the concept of how the taste and smell actually works. Give it like a 20 minutes in YouTube videos. For example, Ninja Nerd, I'm sure many of you know his YouTube channel. He has a specific videos for taste and smell and the sensory system. I would give it a try just to watch it to see maybe I can remember something. It's very hard, but for the IMAT exam, it's very not likely to see very difficult questions about the sensory system. But of course, first of all, when it comes to physiology, if you're still not sure in muscle contraction and action potential and the sequence, the ligand-gated and the voltage-gated sodium channels, the potassium channels, or when it comes to the calcium inside the muscle contraction with the troponin and tropomyosin and all of these names, if you feel a bit off when it comes to these two, make sure to close them before the exam, then move to GI and nephron, and then pretty much move to the sensory system if you have a bit more time. So this is for biology. When it comes to chemistry, I didn't say it last year, but I realized chemistry is something that following the 80-20 rule. So this concept of 80-20 is that, for example, 80% of the capital is being held by 20% of the population. It's something that you can really apply when it comes to chemistry. So 80% of the questions on the IMAT exam actually come from 20% of the papers of the book. And mainly the first 4 chapters of Pearson's, the first 130 pages of Pearson's, 80% every year, almost 9 questions every year, are only on the very, very basic topics. You can see this statistic we made last year. So basically Stoichio, chemical bonds, periodic trends, hybridization, and basic organic chemistry reaction, for example, functional groups, are usually being asked a lot on the exam. So ideal gas laws, solutions, stoichiometry, theoretical yield, chemical bonds, hybridization, Lewis structures, and then you have a couple of questions that are equilibrium or acid bases. But it is mainly these topics that if you feel a bit off when it comes to these topics, I would prioritize the very early pages of the chemistry and the very fundamentals of chemistry. So I would even give a try to, if you don't feel 100% sure, when I study, I use the Pearson's book, and the first 3 chapters are around 120 pages, if I remember correctly. It took me 2.5 days to finish all of the pages, and they give you basically a sequence of exercises in increasing level of difficulty, and because it basically in a sequence, it shows you what you should study. And when you don't understand something, you know where to start it from. So when it comes to stoichiometry, chemical bonds, hybridization, periodic trends, and functional groups, organic chemistry and reaction, I would basically go to the first courses on Enter Med School when it comes to chemistry, or the Pearson's book, the first 4 or 3 chapters. Math and physics is a bit weird because many students, like me for example, because many Israelis, they don't take the exam right after the high school. We take it a couple of years after. We kind of forget the math or physics of high school, and I know many of you actually are non-European and many of you are a few years after high school. This is why math and physics, especially also for me, is a bit weak spot. But what I do suggest is that there are several topics, especially in physics, that even if you didn't study physics in your life, usually on the exam, you will see one question from this topic. And I would give a try in the next couple of days to maybe give it a try to actually study it. I'm talking about Ohm's Law and electrical circuits. You will have basically basic electrical circuits that you need to analyze to find the voltage, the resistance, the amperes, and there is a very specific formula that you can use. And if you want, guys, there is a very, very good YouTube video that I will send you as a summary of the lesson after today, that basically shows you how to do it, how to solve electrical circuits. If you got it, that's good. Try to solve maybe extra exercises just to close it down. If you didn't, it's fine. But this is an example for a question that might appear on the exam, and actually it's 3 points once you understand a very basic topic, even if it's 5 days before the exam. So if you can do it, give it a try. If you don't want to spend the time, that's fine as well. Another thing that is important in math and physics is that the math part is pretty basic when it comes to algebra. So for math and physics, it's pretty much practicing as much as you can, but you need to be honest with yourself if you actually want to spend the time to study math and physics before the exam, or you want to focus on chemistry and biology. The thing about the IMAT is that you will never solve 60 questions, which is so important to remember. You will never reach a point, you really shouldn't reach a point unless you are a genius to solve 60 questions on the exam. So I told myself that I'm going to admit to Pavia, and for Pavia I need around 50 points. I don't want to get more than 50, I want to be sure I will get 50, but I will know that I'm sure 100% when it comes to my questions. In order to get the 50, I need around 40 questions out of the 60. So I told myself, okay, general knowledge, I don't really need to solve it, so maybe I will get some points out of it. Math and physics, I will try to do it at the end of the exam. But overall, I arrived to the exam and I told myself I need to solve only 40 questions. In the next slide, I actually want to show you which strategy I followed, and in hindsight as well, when it comes to, I had close to 100 students so far and close to 800 when it comes to classes, and I realized how important it is to have a very solid exam strategy and to know exactly what you're going to do, even every 5-10 minutes on the exam. When it comes to checking the time, checking how much time you spend on each exam, on each question, it's so important. So last year what I said is basically, 1, you won't be able to solve all 60 questions on the IMAT exam. There is no way, and it's not a good idea. You first, when you do the simulators right now, you should definitely know which subject you're going to start with the exam. For example, I knew I'm very good in biology. It's my strongest subject, so I'm going to start from biology. But last year when I did the marathon, I only said you should start from biology. This year I realized that even when you start from biology, you should start from the easiest questions in biology. The thing about the IMAT exam, it's a 50-50 exam. It's 50% stress and stress management and time management, and it's 50% how you actually know the material, of course. Because it's 50% stress management, you need to take into consideration that in the first 20-25 minutes of the exam, you're going to be very, very stressed. Naturally, you're going to be excited, the cortisol, the epinephrine, you can't really resist it, and it's going to happen either way to many people as well. Exam anxiety as well, it's something that you should absolutely take into consideration when it comes to the exam strategy itself. What I did on my exam is basically, I told myself, okay, Ari, you are going to be stressed at the beginning of the exam, but you have to gain the confidence at the beginning of the exam. So how you actually gain the confidence right at the beginning of the exam? You're going to solve the easiest questions first, as soon as the exam starts, and only then you're going to continue to the hardest question. So many people, what they do is they start from question number 1 all the way to 60. And if the first question of logic is going to be extremely difficult for you, and then the second one as well, and then the third one as well, you're going to basically enter this vicious cycle that you're going to be more and more and more stressed. But if you just took the exam in the first 2 minutes, and you fly through the entire paper, and you mark the questions that you think that are going to be easy, maybe they are shorter, maybe they have keywords that you are familiar with, like chromosomes or genetic mitosis meiosis or things like that. And then the second time you actually start solving the exam, you only solve the questions that you find the easiest. When I did it on my IMAT exam without even noticing, because I only realized it 1.5 years after, is that I solved the vast majority of my points at the first 25 minutes of the exam. And because I solved so many points at the very early stages of the exam, I wasn't stressed at all the rest of the exam. And because I wasn't stressed the rest of the exam, I was able to solve the more complex questions after this stage. So try to divide the exam into 2 sections. The first one, you're going to be stressed, therefore you need to take into consideration and to solve the easy questions first. The second one, when you actually get confident, you're going to solve the harder and more complex questions and basically longer questions. When it comes to logic, you have a very long passage sometime, and it's very hard to read it and follow it when you are stressed. So this is what I realized, something I realized only this year when I analyzed last year IMAT. So I hope it will help you, and maybe try to actually apply it when you do some simulators as well. So another thing that is really important is that, in my opinion, you really shouldn't try to solve the general knowledge right at the beginning of the exam, because same thing as I said when it comes to solving a very difficult questions right at the beginning and become stress, the same with general knowledge, because you can't really know. You might reach a point when you don't score anything in general knowledge, and then you're just going to be stressed for the entire exam, because on the back of the head you have all the time, I have minus 12 questions the entire exam. So it's better to solve the easy questions first, then approach the general knowledge, and then you kind of confident anyway, so it really doesn't matter if you get or didn't get anything from general knowledge. I want to ask you questions, guys. Did you have the opportunity to actually download the flashcards I made 2 years ago for general knowledge? Because actually in 2019 and 2020, 1 or 2 questions every year actually appeared for my flashcards. So I would give it actually a try a few days before the exam. Just fly through the flashcards like 10-15 minutes. You tried but failed. So many. Okay. So I shrinked it down to 600 cards. And it's the highest yield cards because I only left the questions I took from similar exams. Test di Medicina, the IMAT of course, and similar exams from high school in Europe. So guys, if you don't know, go to Enter Med School, go to my profile, in the tabs go to documents, and you will be able to download the Anki deck, the flashcards. You have to use an app called Anki to actually open it. So Anki is an app that's been used by almost all of the medical students. It basically allows you to create flashcards, and you need this app to actually open this file. So if you need my help after the session to actually find it and open it up, make sure to check it out. It's called Anki, like this. I wrote it in the chat. You can do it right now if you want. Go to my profile, go to the Documents tab under my profile on Enter Med School. In the folder, just download you have to pay for Nacho. No, it's free. Anki is free. And my flashcards as well. I tried, but it didn't help me. It didn't open up, so you have to use Anki. I will maybe create a short video after this session, if I will have some more energy after this session, maybe tomorrow morning, and I will show you actually how to do it. But if you want, go to YouTube, write how to use Anki as a medical student. It's such a good app to use when it comes to active recall and space repetition. It's basically give you this algorithm that gives you the flashcards over and over and over again. And this way I basically passed my physio and anatomy and all of the exams only using this study technique. It's really important. Anki is not free. It's not free for iOS, but for the rest of the platforms is completely free. So you can get it for Windows for free and for Mac as well. If it said that you do the general knowledge at the beginning, then your brain has more time to remember. You can fly through the general knowledge. Basically what I said when it comes to the exam strategy, you should fly through the entire questions, the entire paper in like the first 2 minutes. And then because you saw some keywords, and for example in physics, if they say something like solubility or ideal gas or kinetic energy, or you will be mentally prepared to actually solve the questions after 20-30 minutes because you know you are expecting this type of question. But when you are basically taking the couple of minutes when you start the actual exam to analyze what the paper is, just highlight next to the question itself if you think it's easy or not. Then try to solve them and not try to solve it in sequence. So as I said in logic, if you have a very difficult question, you might be very stressed. The same when you start in sequence from biology, which is also very important. Another thing that I was talking about last year is to reach a point where you actually allow yourself to guess. So it's really risky, so I don't suggest to do it if you didn't pass the limit of questions you set yourself to solve for sure. So what I told myself in 2.5 years ago is that, okay, Ari, you need to get at least 50 points. How I'm going to do it? I need 40 questions solved. But I knew I'm going to reach a point where I solve 40 questions, but I have extra questions that I reached a 50-50 situation. And even though it is 50-50, I had this gut feeling that one of them was correct. And I allowed myself to guess. But I only allowed myself to guess when I reached the 40 that I'm sure of. And I had the gut feeling, and only if it is 50-50, which is the most critical part. Because it is 50-50, you are statistically likely to get more points than losing, because it's 1.5 and minus 0.4. So if you solve 3 or 4 and you got 2 correct and 2 mistakes, might be worth it. But again, it's very risky. It's something that you should actually practice when you do the simulators, and only do it at the very, very, very end of the exam. And last thing, and I highlighted it because it's so important, never try to solve the entire exam. And also very important, never try to struggle with the question. So something I see with many of my students, and in general when it comes to exams, because you want to prove yourself that you know something on the exam, and because you are very stressed, time flies on the exam. So you might struggle with the question for 4, 5, 6 minutes, and you need to remember that this question, even though it's extremely difficult, it's still worth 1.5 points. So skipping a couple of questions ahead, finding a couple of easy questions that you can solve instead of this one is way smarter. So what I'm saying always is, when you reach a point that you struggle with a question and you see the time and it's like 2 minutes, 2.5 minutes, limit the time, know exactly how much time you're going to spend on a difficult questions. If you struggle more than X minutes, usually it's 3 minutes, skip the questions. Skip the question, but make sure that you mark it as a question that you need to go back to in the second round of the exam, if you had the time, of course. Another extremely important strategy is how to actually tackle the questions. So there is a very specific strategy that many people follow in many different type of exams when it comes to questions that you should actually analyze, and you have tricks. There is an exam called the NEET exam, which is the Indian medical admission exam. And the questions on the NEET exam are extremely straightforward. There are no tricks. It's very binary. You know it or you don't know it. On the IMAT exam, if you know it, you might still get the question wrong. And this is the thing about the IMAT exam. They write the question in such a way that you have to take the extra time to analyze all of the question, to understand what is the trick, and then to solve it. You shouldn't be on autopilot and just solve it, but you should use a very specific strategy to actually tackle the question. And what I usually say, I follow 5 5 steps to actually approach the question, and we are going to implement the 5 steps together when we are actually going to solve the next 25 questions. What I'm doing is step 1, I read the actual prompt of the question. So you have the actual question under the text itself. This is the actual question. I read it first, I make sure I got it and I know what they expect for me to actually find in the question. Step 2 is I read very, very slowly, and I will show you why, because the brain sometimes is doing many funny things when it comes to reading questions. Extremely slowly, and when I reach a word that is not a regular word, like value, number, definition, a keyword that gives me a hint inside the questions like must or all or this type of words, I highlight it, and when I highlight this type of word, I ask myself, what is this information? What do I know about this piece of information? And can I actually apply it to my question? Is it related to my question? Or is it just something that give me a redundant piece of information that I probably can't use it and it's only to confuse me? I really ask myself these questions inside my head to make sure I know completely the question, and then I approach the answers themselves. When I approach the answers themselves, beyond the fact that you also, of course, have to sketch as much as you can on the paper, I'm basically removing as many answers as I can. While I remove each answer, I always convince myself that I'm correct and I'm not doing it on logic or gut feeling. It's very easy to answer or to remove answers because of logic, based on logic or gut feeling, and it's something you should avoid always. You should convince yourself based off what they give you on the answer, in the question, or what you know that you are correct and this answer isn't correct. So I remove 1, 2, 3, 4 answers, then I reach the last one, and what I'm doing, I'm not highlighting, I'm not basically choosing this answer instantly. What I do is that convince myself that this question is correct again. And you're going to see how we're actually going to implement it in the next couple of questions. So now it's the most important part of the class. It's very important to me to say, like a disclaimer, the questions I brought today are very difficult and very tricky. Out of all of the questions I analyzed in all of the exams, all of my students so far had close to 80-90% mistakes, and I know these questions are very difficult. However, don't let it demotivate you or stress you out. It's not correlated to how much you know. It only shows you how tricky the questions can be. But once you analyze this sort of tricks and you notice they do this sort of tricks on the IMAT exam itself, it's going to be really straightforward for you. So the first question will be one of the easier question, and I'm going to show you this question right now. So please let me know in the chat if you can actually see the question. You can't, yes. Okay, if I will zoom it like this, can you read it now? Yes? Okay, perfect. I'm going to start a timer. Let's give it 1 minute and then we will solve it together. Try to use the steps I showed you. Please zoom in more, of course. We're gonna answer in the chat or poll. I think maybe we should answer after the time is up, so we won't do spoilers. But I see from the chat that all of you got it correct, which is pretty straightforward question. But I brought it because of a very specific reason. I want to ask a question. But answer it seriously. Any one of you actually recognize the word off appeared twice here? Let's see. If you did, that would be really shocking. You didn't, right? So this is an example of how the mind actually works. If you don't read the question extremely slowly, the brain works in a very templative way and it expects a very specific template. He knows the word off will never appear twice, it just skips it. And it can be a lot of times on the IMAT exam itself. This is why I always insist that it's so important to actually highlight the very, very important keywords and read it extremely slow. And when I do it actually, I make sure I invest extra 40-50 seconds for each question, but basically I save myself these small mistakes and I close the question completely. Another thing that let's solve the actual question itself. Of course, first of all, which thing we actually highlight in the question, let's follow step 1 and 2. So an mRNA molecule, I'm going to highlight it. I have a number, I'm going to highlight it as well, 60 nucleotides. Start and stop codon, the number of bases of this mRNA molecule other than those in the start and stop codon is. Now I'm asking myself, step number 3, what? Can you please make it smaller? I can't read the whole question. Yeah, of course. Is it better now, guys? Sorry about it. Maybe next time I will use Zoom. The quality of Google Meet is a bit off. I can also stream it to YouTube at the same time if you want and you can watch it. Yes? Okay. So now I'm asking myself basically what I know about each keyword. So mRNA, very quickly, it's a single strand. We have U instead of T. Just the general thing I know about each keyword. 60 nucleotides, what do I know about it? Okay, nucleotide is a nitrogen base with ribose and phosphate. I don't know, maybe I will use it, maybe I not. I'm just saying myself whatever I want. Start and stop codon, what do I know about codons? Codons are 3 nucleotides. The number of bases in this mRNA molecule other than, which is extremely important, the start and stop codon. Now even though it's a very simple calculation, I'm going to draw it down anyway because I'm coming from a place that I'm saying myself, I might be very stressed on the IMAT exam, and even though I know this very easy calculation, which is 60 minus 6, I'm going to write it down anyway. So 60 minus 3 equals 54. This is the answer. Anyone understand, right? You all follow this strategy? How I actually approach the question? I wanted to give a very easy question to begin with, because I wanted to show you how I implement my strategy, my 5 steps. But that might be less. What do you mean, Erfan? Less nucleotides? Okay, so I mean, mRNA doesn't necessarily start with a... So what they are saying, the thing is, what I noticed is that sometimes when you have a lot of knowledge on a subject, you might think that the question is harder than what it actually is. Every year on the IMAT exam, especially the biology and the chemistry parts, they are divided into very easy questions and very difficult questions. So the very easy questions are usually extremely straightforward, and the very hard questions are not. But these questions is extremely easy, but it might basically scare you a bit because you tell yourself it's too easy, and where is the catch? Where you try to find the catch, you might basically put a stick in your wheel, basically. So does stop codon UGA UGG code the amino acid, just like start codon AUG? The stop codons don't code for amino acid. They code for something called basically a factor, a protein called factor. It answers the ribosomes, but the tRNA itself doesn't bring any sort of amino acid. In the question, would you have been number of nucleotides? Is this mean mRNA in place of bases? What strategy to apply? The word bases and nucleotides are basically the same in this question. Do you guys remember the difference between nucleoside and nucleotide? So nucleotide and nucleoside. So nucleotide is the nitrogenous base, בדיוק, exactly, the phosphate. Ribose, phosphate. Nucleoside, remove it. So we get rid of the phosphate. One has phosphate, exactly. Sometimes they do it because it's very similar definitions. They sound the same. Cambridge are very likely to try to confuse you. This is why I highlight all of the keywords, because then I maybe find a different keyword or different word that sounds the same, and if I read it too quickly, I thought it was nucleotide instead of nucleoside, for example. Another thing that is very important to remember are the differences between the translation and transcription of the prokaryotic and eukaryotic. So in prokaryotic and eukaryotic, you have specific things that you must remember. For example, do you guys remember, and feel free even if you want to open your camera or to say in the chat, what is the main difference between the transcription of eukaryotic cells and prokaryotic cells? In a few words. Let's see. Location. That's true. What else? Maybe chemical modifications. So basically the cup, exactly. So in eukaryote you have something called chemical modifications. So when you have the actual mRNA, it doesn't called directly mRNA. We call it pre-mRNA, because this pre-mRNA needs to go through a couple of steps to actually mature into a mature mRNA. We do two main things. One is we take the pre-mRNA, and in the 5' we put a modified guanine guanosine head in the 5 cap. In the other side, in the 3', we put something called poly-A tail, polyadenine tail. The second step, and both of the steps are inside the nucleus, is something called splicing. Do you remember, guys, what do we splice out of the pre-mRNA? Introns, exactly. So we splice the introns outside, we keep only the exons. Only then it's going to leave to the cytosol and to meet basically a free cytosolic ribosome. On the other hand, you have the prokaryotic cell. The prokaryotic cell basically have everything happen inside the cytoplasm because they don't have membrane-bound areas and organelles. Therefore, the transcription and translation occur, both of them, inside the same time and the cytoplasm. You also don't have GCAP, poly-A tail, or splicing, but you do have operons. For example, the LAC operon or the tryptophan operon. Both of them are very important to remember for the exam. So if you find it a bit difficult or you don't recognize the word operon or the word LAC operon or tryptophan operon, I would give it another look, because this is very high yield for the exam. Another important thing that I would like to ask you is that what is the main difference, or is there any difference between the ribosomes inside the eukaryotic cell and prokaryotic cells? Size, exactly. Which one is bigger? So you have this hamburger for the prokaryotic cell and the same for eukaryotic cell. And what happens is that prokaryotic are smaller. They are 30, 50 S and total 70 S. And on the eukaryotic side, it's 40, 60, in total 80 S. I just remember it for 4, 6, 8. And for prokaryotic side is 3, 5, 7, odd numbers. One important thing that I would like to say is that on the IMAT exam, they really like to confuse you when it comes to what you can find inside eukaryotic cell. For example, there was a question on one of the exams, I'm not sure which one. They ask, do you have circular DNA inside the liver cell? So I will ask it again for you guys. Do you have circular DNA inside eukaryotic cell? Exactly, in the mitochondria. So I will ask you another question. Do you have 80S ribosomes or 70S ribosomes inside the liver cell? Which type of ribosome will you have? Both, exactly. So they expect you, when it comes to the IMAT exam, to zoom out from what you are expected to think of. For example, when you hear the word nucleotide or genetic material, you are immediately zooming in on the nucleus, for example. What you should do is to even draw the entire cell, to zoom out and to basically try to imagine everything. So I tell myself, what do I have inside the liver cell? I have the mitochondria, I have the nucleus, I have the Raphiar, I have the Golgi, I have peroxisomes, lysosomes. Then I ask myself, what do I have inside each one? And then I realized inside the mitochondria. Because I took the extra couple of minutes to actually analyze this, it was really straightforward for me. Wait, my roommate is calling 5 times. Sorry guys. I think it's urgent. I will be back in 2 minutes. Very sorry guys. Sorry guys. Okay. It was urgent though. What is the difference between loop DNA and circular DNA? It's pretty much the same. However, loop DNA might and circular DNA, they might appear in single-stranded, so you need to make sure that you know, for example, if it's a plasmid, it's double-stranded for sure. But usually they use it the same definitions, the same definition for both. So it's equivalent. Let's solve another question. This time we will solve this central dogma question. I will try to zoom it in a bit more. Does the mitochondria have a 70S? They have a 70S. Some sources say they have a 65 or 55S, but in general, remember that the mitochondrial ribosomes are very similar to the ribosomes you have inside the prokaryote because of the endosymbiotic theory. That the prokaryote basically enters a eukaryote to live symbiotically. So this is why you have both type of ribosomes inside the eukaryotic cell. I will give this question another minute and we will solve them together as well. Guys, let's try to write the answer in the chat only after the time is up, so we won't do spoilers. Do you guys want another couple of seconds to solve it, or did you manage to solve it? Managed? Okay. So let's go through the question itself and how we actually tackle this sort of questions, because it's extremely important, especially this type. So let's read it very slowly and use the method I always use. So the following shows a transfer RNA, so tRNA, triplet with the associated amino acid, basically a codon chart for the tRNA. Which DNA sequence listed can make a protein contain the sequence of amino acids? And then they give me the actual sequence. So this one, so AUC, then this one, so AAG, then it will be this one, which is CUA, and then it will be this one with the GAA. Is it 3 to 5 or 5 to 3? The direction itself. Let's see. Do you remember? tRNA is 3 to 5 or 5 to 3? 3 to 5, exactly. So this one will be basically 3 to 5. How can we go from this tRNA to the actual DNA? By the way, the DNA that we are given in the answers should be the coding strand or the template strand. Let's see. Template, exactly. And the template strand will be 3 to 5 or 5 to 3? Exactly. Because it is 3 to 5, you can use a very specific trick to actually convert this tRNA strand into basically the template strand. So let's first of all talk about what in general we are expected to do. We need to this one to convert it to mRNA, and then from mRNA to DNA. So it will be one complementary and then another one complementary to the mRNA. Then we will reach the template strand of the DNA. What we can do, however, is because you need to replace and to change twice, back and forth basically, this strand to the complementary and then the complementary to this one back. What we get is basically that the DNA is going to be this exact strand, but we are only going to change U to T. So if we want to go from tRNA to the template strand of DNA, all we need to do is to change the uracil, which you can find in RNA, to T, which you can only find in DNA, because they are pretty much the same. We did the complementary sequence twice, therefore it basically returned to the original one, but the only change is the T instead of U. So this is why the answer is C. Another trick that you can do on the IMAT exam itself, that you don't have to write down the entire sequence. What I did basically when I'm approaching this type of questions is I'm only checking the first sequence, the first codon. So this one, this one, this one, this one, and this one. First of all, B is not correct because you have uracil and you don't have it inside the DNA. So I will remove it. But the four more, the rest of the four of the answers basically, all of them are different codon. Therefore, they must basically code for a different amino acid. So it means that we can basically check a single codon and to get our answer. And what I will do is I will only take AUC, and I will only this one, I will convert it to ACT, and then I get C, which is the only one that actually starts from ATC. So this is two tricks you should actually give a try when it comes to these questions. And especially important to remember the sequence. So you have coding strand, which is 5 to 3. Then you have the template strand, which is 3 to 5. From the template strand, we are going to code the mRNA, which is going to be complementary to the template strand. Therefore, it is going to be 5 to 3. And this one is going to be complementary to the tRNA, therefore it's going to be 3 to 5. Does it make sense, or you have some questions, guys? Let me know, because I'm going through some topics a bit quick because I want to do a lot today. How do we know the sequence is changing or not? It must change because when you create another one based on the previous one, it must be complementary. So template strand, it's 3 to 5 because you can only sequence mRNA from the 5 to 3. So you will have 3 to 5, but the mRNA from it will be 5 to 3. But prokaryote and eukaryote, what is the difference between loop DNA and circular DNA? Usually they say that the nucleode inside is a circular DNA called the nucleode, which is a single chromosome, and sometimes loop DNA is usually referred to the plasmids inside. So the main one is the circular DNA that all of the prokaryotics have, and then some of them will be able to actually contain more loop DNA, which are the plasmids. Is it reasonable that the first mRNA codon is not AUG? It will always be AUG if it's the start codon. However, they can give you basically a strand of mRNA that is a part of the DNA, not the entire thing. So it's possible that you don't have the start codon inside. Can you explain how it be if the question was asking about mRNA? Of course. So for example, if they will give you the mRNA, so let's assume this chart is for the mRNA, and they give you mRNA and they ask you this one. This time, because the DNA itself is always the template strand when it comes to the proteins, because only the template strand will actually give you the mRNA and then the tRNA, the protein, it means that the mRNA itself is 5 to 3, and it is complementary to the DNA, which is 3 to 5. And by complementary, I mean if you have A here, let me choose another width. So if you have A here, what actually completes A? Which nucleotide? Let's see. Exactly, you get U, but because it's DNA, you will get T. So let's say we have AUC, it will be T, basically A and G. If the questions was asking the microRNA to silent the part of the gene, how would it be? And how about the 3-5 part of the microRNA? I've seen this in some Humanitas exam. On the Humanitas exam, it was a horrible question, I saw it as well. What they did is that microRNA is basically something that can help you modify or silent or cut different part of do modifications to the strand. The thing is that it is complementary to the strand that you are working on, but on the Humanitas exam, they added an extra step. They said that the microRNA is going to work on an enzyme, and the enzyme is going to work on the mRNA. So you had to change it once and then twice. But in general, microRNA should be complementary to the mRNA. But these type of questions are very, very rare. And I'm sure I confused a couple of people here who don't really sure which questions we are talking about. So if you guys want, I can send it on the post as well. I will write it down. It's a good question, but it's not very likely to appear. MicroRNA is the same as tRNA then? You could say yes, but part of it. So we don't have codons, but microRNA is expected to be complementary to the mRNA because of the hydrogen bonds that the microRNA and the mRNA form. You are able to actually do the modification. And you do it by basically being complementary to the other strand. A quick reminder, how many hydrogen bonds do we have between G and C, and how many do we have between A and T? 3 and 2, exactly. This is very important as well. One of the easier questions on the IMAT exam is when they give you a sequence of DNA and they tell you what is the percentage of pyridine, for example, and then they ask you how many you have left, so you just complete it based on the number of hydrogen bonds, because you know they are complementary to each other. Perfect. let's keep going, guys. This question is the hardest question, but it looks easy. So I will give it 2 minutes, and I want you guys to really think what is the answer. And after the 2 minutes, I'm going to really explain it because it's so important. So make sure, please don't to say the answer in the chat, and we will go through it together after the actually 2 minutes. Guys, go in a few minutes to my latest post on Enter Med School, and I will just upload this PDF to the website. You can download it, and if you find it a bit blurry to look at the question, just download it. Okay, you can find the PDF in the latest post on the website. So if you couldn't see it, you can just download the PDF. Okay, so the chiasmata is the point. Yes, exactly, is the point of the causing over. So what is the answer, guys? What do you think? Okay, D, C. Mark is a master so far. So C, D. Okay, many say C. That's very good. Yes, C is the answer. This question is extremely important, and last year when I showed it to my student and during the marathon, it was pretty much it appeared, this sort of questions appear on the exam, but beyond it, the concept itself is so important. So I would like to emphasize on it and maybe take 10-15 minutes to actually explain you guys which steps you should follow. So I will ask you a few questions to see if we are all on the same page. Let's take a somatic cell, a liver cell, for example. I will take a cell and I will look inside the nucleus. I have the interphase, the cell cycle, which is of course built from G1, then S, then G2, and then the M phase. And then after the M phase, separately, you have the cytokinesis. You also have sometimes some cells that go to G0. Do you remember, guys, that where the actual synthesis, where the actual replication of DNA occurs, in G or S? In S, exactly. Why is it important? If I would ask you how many DNA molecules do you have before the S phase inside the nucleus and how many DNA molecules do you have after the S phase in a human liver cell? This one is tricky, so try to think about it. 46 and 92, the same but double the chromatids. Exactly. So what actually happens? We don't actually have chromatids or chromosomes, because chromatids and chromosomes are the most condensed way you can actually organize the DNA, the genetic material. But assuming we do, the thing is that before the S phase, you're going to have 23 DNA molecules from the mother and 23 DNA molecules from the father. After the S phase, you are basically going to have 46 DNA molecules from the father and 46 from the mother. The thing is that each DNA molecule with a lot of proteins inside is going to give you 1 chromatids. And you're going to have 2 of the same DNA molecules, because it's basically you replicate it. So you're going to have 2 sister chromatids. But the sister chromatids, instead of this one before the S phase, it's going to be this one after the S phase. The thing is that you have in both of them a single centromere. So 1 centromere here and 1 centromere here. Because you have single centromere, you will have in the future, of course, you can count directly the number of chromosomes. So if someone asks you, give you a picture of a cell that goes through the metaphase, the M phase, and he asks you basically how many chromosomes do we have, just count how many centromeres do we have. So the number of centromeres is directly give you the actual number of chromosomes. It's so important to remember. Another question is that what actually happens during M phase. So during M phase you have a stage called the metaphase plate. Let's take a liver cell that goes through mitosis and a sperm cell that goes through meiosis 1. And we will zoom in the cell and we will say that it's in a metaphase of meiosis 1 and the metaphase of mitosis. Will the chromosomes, the homologous pairs, because you have sister chromatid from the mother and sister chromatid from the father, but still this, for example, is chromosome 1 and this is also chromosome 1, therefore they are homologous pairs. Will they actually align one next to each other or one on top of each other? Do you remember? Let's see. It's a really tricky question, so I would like to see if you guys remember. Mitosis next to, okay. Next to each other. In mitosis or meiosis, Agatha? Attached to in meiosis. So what happens actually? Let's take only chromosome 1. We have basically 46 chromosomes. We are going to have only chromosome 1. What we are going to have is the mother, sister chromatid, so imagine 2 here, and the father, sister chromatid as well. In mitosis, all of the chromosomes are going to align one on top of each other. So you're going to have a single metaphase plate. But what happens in meiosis, they're going to come next to each other. So you're going to have 2 metaphase plates. So how many spindles will we have from each side of the pole of the cell in mitosis, in meiosis 1 of a sperm and liver cell of a human? We will have 46 in mitosis, basically 46 hands from each side, because all of the chromosomes are in the middle. But in meiosis we are going to have 23 spindles, because they are next to each other. Do you guys want me to explain it again? Because it's so important for the exam. Okay. So the idea is that in mitosis, we are going to split the sister chromatids. Therefore, as soon as we are going to split them, we are going to have double the number of the centromeres. And what happens when we double the number of centromeres? We have double the amount of chromosomes. However, in meiosis, we are not going to split them by the sister chromatid. We are going to glue 2 chromosomes together. And then in meiosis 1, we don't separate the sister chromatids. We just separate this glue between them. So we didn't double the number of chromosomes when it comes to meiosis 1. So if I would actually draw mitosis, I will have one chromosome, another chromosome, another chromosome, another chromosome, and another chromosome. So let's say this one is chromosome 1, this from the father, and this one is chromosome 1 from the mother. This one is chromosome 2 from the father, paternal, and this one is chromosome 2 from the maternal, the same as this one. This one is going to be maternal 3, and this one is going to be maternal, also paternal, also 3. These are homologous to each other. These are homologous to each other, and these are homologous to each other, but all of them are going to be aligned in the metaphase plate, one on top of each other. Therefore, because we have 46 chromosomes inside the human cell, somatic cell, we are going to have from both sides 46 arms that are touching to the chromosomes. So one here, one here, one here, one here, one here, one here, all the way to 46. However, when it comes to the meiosis part, the homologous pair are not going to be one on top of each other. This time, the homologous pair is going to come here, and this homologous pair is going to be here, and this homologous pair is going to be here. They're going to be one next to each other. Therefore, instead of 46 arms from both sides, now you don't need 46. You need 23 arms, because you basically set them in pairs instead of singles. So from the centrosome, from each side, we have one here, and one here, one here, one here, and one here. If I will zoom in, I will remind you guys that each chromosome, each sister chromatids, have one centrosome. Here, 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 and here. They are glued together to each other through a complex of proteins that basically holds them together in between. In meiosis 1, we basically break this complex of proteins, but we don't break, like in mitosis, the sister chromatids. However, in meiosis 2, we do going to break the sister chromatids, therefore we do going to increase to double the number of chromosomes. I know it's really confusing, but it's really, really important to understand. These two hands are called one spindle, so this one is a spindle, and this one is a spindle. Guys, do you remember what are the spindles made out of? Which cytoskeleton part it is made out of? Microtubules, exactly. And inside each centrosome, what do you have? Two centrioles. And if I will take one centriole and I will cut it inside and I will look inside to the structure itself, what do we have inside the centriole? What is the basically how the microtubules actually arrange inside the centriole? In triplets, exactly. So we'll have 9 triplets of microtubules inside one centriole. I'm going to have 2 centrioles in one centrosome, and I'm going to have 2 centrosomes during M phase. And it's so confusing to remember all of this, but it's really, really important. If I will take the cilia and flagella, for example, so we'll have a cilia, and I will have a flagella. If I will basically cut it right here, like I did with the centrioles, and I will look inside. What is the structure that I'm going to look inside and find inside? Exactly. 9 plus 2. So we are going to have, instead of 9 triplets, we're going to have 9 doublets, like this. Imagine I have 9 here, I didn't count, and in the middle I have 2. So it's 9-2 arrangement. However, you're going to have something extremely important for the exam. Do I have the same arrangement when it comes to the flagella or flagellum when you have in prokaryotes? Do I have a 9 plus 2 arrangement? Let's see. You don't have. Why? because inside, and it's so important, and this is when it comes to actually saying you need to know the differences between the prokaryotic and animal cell. In the prokaryotic cell, we don't have microtubules, we don't have microfilaments, and we don't have desmosomes. We have completely different sets of protein that have similar function but different structure. So you don't have microtubules, therefore you don't have ciliary flagella. And if I will take the protein that compose the flagellum, which has a very similar function but completely different structure, it's going to be composed out of flagellin. So if they will ask you inside a prokaryote cell if you have tubulin or actin, for sure you don't have. So cytoskeleton parts that come in eukaryotic cell are completely different than the part we have inside prokaryotic cell, and this is something people don't think of, because they see the structure of flagella that is very similar to flagellum, and they think therefore microtubules are also inside the prokaryotic cell. So once you remember the difference, it's really, really important as well. So when it comes to mitosis meiosis, this is how I'm actually able to count the number of centrioles, the centromeres, and chromosomes. I hope it made sense. I'm recording this session anyway, so you will be able to actually watch it again. And of course, after this session, or tomorrow morning at least, I'm going to link all of the videos I mentioned today in the post I uploaded to Enter Med School Now with a PDF. So there are really good YouTube videos that explain this concept. So make sure you know how to count the number of chromosomes. Also from last year, the PDF of the marathon, which I will upload, there is, and also in the worked solution, by the way, of the simulator I wrote, I showed like in 3 pages, step by step, how to count everything. So if I was a bit too quick, and I assume I was because I want to touch as many subjects today, you can read basically the summary in the work solutions of the simulator on the website. Let's try to solve this one. What do you think is the answer? Ari, do you know how to get green pass or for non-EU for the exam? I really don't actually. I'm not updated when it comes to the green pass. I need to get it myself and I have no idea how to do it. I will try to look it up, but maybe it's better to ask on the WhatsApp groups or Telegram groups. Sorry. Okay, I see almost all of you got it correct, which is, and it is a very tricky question, so I see there is a bit confusion between A and E. So let's try to use the steps I showed you at the beginning of the marathon to actually approach this question. So the diagram represents a whole DNA plasmid that has been cut open using a single restriction enzyme. Okay, I basically highlighted all the words that are not regular words. Now I'm going to ask myself, what do I know about these words? So DNA is double-stranded, plasmid is circular. Okay, circular. Single restriction enzyme basically cuts the hydrogen bonds between in a specific set of double-strand, basically genetic material, opens it up and leaves that with the sticky ends. Do you remember the sticky ends, or do you want me to talk about it a bit? Okay, so in biotechnology, you have basically a way to cut open genetic material. You use something called single restriction enzymes or multiple restriction enzymes. A restriction enzyme basically let's say I will have this double strand DNA. it will cut right in the middle, the hydrogen bonds, and then you have this complementary and this complementary, and once I open it, I'm going to have something that looks like this. An open plasmid or circular DNA with this some sort of flop of single strand, and the other one here, and this one and this one are called sticky ends, because basically they are the free parts we can stick together back. It means that because we use a single restriction enzyme, it means that this must be complementary to this one. But because I've read the question very slowly, I know that a plasmid is circular, therefore this part must enter all the way to this part, because we need to close it like a bracelet. So 5 must enter all the way inside, and then the answer must be A and not E. And of course B, C and D are not possible because you don't have uracil, because I highlighted the word DNA. Does it make sense, the explanation? It's basically an example of a questions you really need to read it very slowly, even though it's a very short question. And for example, you have the word DNA, which is in capital letters. It's very easy when you read it very quickly, as I showed you at the beginning of the lesson, when the word off showed up twice. It's very easy to skip this, basically this word, because this word is in capital letters, and you read it quickly, you just skip plasmid. And then if you didn't read it very slow, you will see that if you didn't highlight the word plasmid, you don't understand the question. Could make it harder by changing the numbers. Which numbers, Sina? Does it matter at all how many bases are in between? Not really, because the concept is that this was circular, so you can have even 1 million inside. As long as you have this part and this part, they are 100% sure they are the edges of the circular DNA. Does it matter how many bases? So no. I hope it explains it. If it's not, if you guys have any questions, let me know. Alright, let's keep going then. So as I showed, this one is the only correct answer because these are sticky ends. Let's do a chemistry question, and it's a question that combines a lot of different topics together. So I will give it 1 minute as well. Okay, perfect. So what do you think is the answer? Or do you want maybe an extra minute? Okay, so A, a lot of A. That's good. That's very, very good. But all the people who answered A, because I know many of my students have a lot of trouble with it. Did you see the answer previously, or do you actually got the A? No. You did it? Okay, fair. Anyway, let's try to analyze the question. And because it is extremely important question to understand, it talks about solubility, vapor pressure, and ideal gas laws at the same time. So let's really try to break it down. So the following statement refer to water or solutions in water. At high altitude, where the pressure is less than 1 atm, the boiling point of water is below 100 C. From general knowledge and from the actual knowledge you need to from the chemistry syllabus, you should remember that the less you have the vapor pressure, the less energy you will need to invest in order to boil the molecules. I will explain it in a different way. So let's take a cup of water, and let's say I'm outside right now, exactly at sea level. So I have molecules from the sky all the way down until the surface of my glass of water, pressing down of my glass of water. It means that all of these molecules basically prevent the water molecule, the liquid water, to escape and become gas. The less power, the less pressure I'm going to press on the surface of this water, the easier it will be for the water molecules to actually escape and become gas. Which means that the less pressure you will have, the less energy you will have to invest, therefore the lower the boiling point of the actual liquid to become gas. Does it make sense? So for example, if I will go on a mountain and I will have less molecule pressing down of my glass of water, I will need to invest less energy to actually help them to escape this liquid and become gas. This is why 1 is correct. 2 is also very important. So the freezing point of sodium or solution of sodium chloride in water is below 0% at 1 atm. What happens when you want to go from liquid to solid? You basically want to create a lot of temporary hydrogen or intermolecular forces, bonds between the different molecules. Because the ions of the sodium chloride are going to interfere with the water molecule from actually touching each other, it's going to be harder for the water to go from liquid to solid. Therefore, it's basically going to cause us to lower the freezing point, because we need to slow them down even further. Because remember that by definition, temperature equals kinetic energy of the particles. And 3, this is correct. 3 is something that you can solve in 2 ways. The ideal gas law and also just logic. So I will use logic because I was able to break down the answer using the steps I showed you. So the average kinetic energy of steam molecules of pressure of 200 atm is greater than in 1 atm at the same temperature. So what they say in the question is that the average kinetic energy equal temperature, because kinetic energy of particles by definition is the temperature of steam molecules, which is gas, at pressure of 200 is greater than 1, but at the same temperature. So what they say, basically, you have bigger kinetic energy at the same kinetic energy. It doesn't make sense. You can also solve it by using the ideal gas law and to actually prove it that this one is correct. So if we take the ideal gas law, which is PV equal nRT, I will just set the different things inside. So T is going to stay the same. It's not going to go up, it's not going to go down. However, P is going to become bigger. Therefore, which part of this equation, which part of this formula actually going to change in order to compensate on the change of pressure instead of T? V, exactly. This is how I actually basically convinced myself I got the question correct. Beyond the fact that you can solve it using logic, because it's basically the same temperature and different kinetic energy. It doesn't make sense. So therefore, A is the answer. And if you want to review this type of question, I would review solutions, vapor pressure, ideal gas laws, and the definition of pressure, volume, and temperature. Temperature is the basically kinetic energy of the particles. Pressure is the force per area. For example, what is actually pressure? If I will take a container, for example, with a specific number of moles inside of gas, the molecules are going to touch and hit the different parts of the container per area. If I'm going to have the same molecules, but the volume is going to be less, I'm going to have more molecules hitting specific part of the surface area per area. Therefore, the pressure is going to be higher. This is why it's very important to understand the actual definitions of the different things. When it comes to volume, of course, it's just the size of the container. Guys, do you have any question? Because it was a bit difficult question. Okay, perfect. Let's keep going then. I would like to do one questions from biochemistry and one questions from Lewis structure before we actually finish the session for today. So let's try to do this one very quick. I will give you guys 1 minute. Okay, so what is the answer? Okay, so A. That's very good. That's really good to see, by the way, guys. The questions are not very easy. For the example, this one is quite a lot of memorization. You need to remember all of the bonds and the angles. So it's really nice to see you guys really solving so many questions correct. You should be really confident before the exam because the questions were pretty difficult, especially the chromosome, the chiasmata question is something that many people don't really understand. It's easy because I know the answers. Well, that's fair enough. If you do, before the IMAT exam, I always say that you shouldn't study from the books, all of the exam, all of the material, and try to cover as much as you can. You should analyze as many questions as you can from the IB, IMAT, BMAT, TSA, and from the questions, study what you don't know. So if you have a lot of questions you already solved, that's perfect. You can use the IB as an extra source because I think many of you didn't use it yet. So I will give it a try. Just go to ibdocuments.com. You have close to 40 years of questions. And because the exam is conducted by Cambridge, they are perfect. Let's go through this question quickly. So because many of you got it correct. Where can we find the IB questions? On ibdocuments.com. Which of the following answer correct statement about NH3? For me, because when I used to study for the IMAT, I solved so many deep type of questions. When I see NH3, I immediately know the structure, which is N, 1 bond, 3 bonds to H, and a lone pair of electrons. So 3 bonds, of course, of H, and 1 lone pair. So the problem is between A and D. And only from memorization, you should remember that this one, which is a trigonal pyramidal, is 107 degrees. Another easy way to actually understand this concept is by understanding, for example, if I will give you this molecule, methane, which is CH4, how many degrees will we have between the arms of this molecule? So it will be like this. What will be the actual angle of this molecule? 109, exactly, 109.5 degrees. Because we remove this one in ammonia and we replaced it with a lone pair of electrons, the repulsion of electrons is a bit stronger than a covalent bond. Therefore, from 109.5, we are making it 107. And let's take another one off and add an extra lone pair, which is a molecule we know, which is called H2O. This time it's going to be less than 107. It's going to be 104.5 or 105. The idea is that lone pair of electrons is going to have bigger repulsion than a covalent bond. So it makes sense to answer the following table. This one. But anyway, this is a table. Basically, it's all of the commonest molecules that will appear or appeared on the IMAT, BMAT, and IB exam. I would say memorize the following molecules. It's not a lot, and it's really, really important because these type of questions are pretty much 3 points when you actually understand it. You can find this table in this PDF. I uploaded it to the latest post on Enter Med School. Let's do this one. So what do you think is the answer? I see A, okay. I see B. What else? I see D. C, D, okay. The answer is actually C. And it's so important because this question is just a combination of so many tricks you should know and notice on the IMAT exam. So first of all, let's go one by one, and I will show you first of all how I answer this question. So which row correctly matches each cell structure and the function? I understood the question, I'm going to go to the question itself. I have a list of microtubules, and I have a list of rough ER. I tell myself, for example, I feel more confident when it comes to microtubules, so I will try this one first. So allow vesicles to move within the cell. I'm going to draw down the cytoskeleton, and I'm going to remember that I'm going to have the different rows of microtubules. On top of them, the motor proteins, which are going to hold the vesicles. Therefore, this one is correct. Form cilia and centrioles. Is it forming the cilia and centrioles? As we said, yes. Centrioles are 9 triplets and cilia are 9 plus 2. They do form it. Therefore, this one is correct as well. Form the spindle during prophase. Is it form the actual spindle during prophase? I'm telling myself the spindles come out of the centrosome, which are made from 2 centrioles, and the centrioles are made from microtubules. This one, that's a funny glitch. This one is correct as well. Then now D, move chromosomes. So move chromosomes during anaphase. Let's say I will write down anaphase quickly. I have this part. Who moves them? The spindles back to the poles. Therefore, yes, they move the spindles. I convinced myself all of them correct. The second part is extremely important. So check this out. The rough ER is indirectly and directly associated with amino acids and protein. Therefore, most of the answers they are going to give you are going to be either indirectly and directly related to proteins in order to confuse you. But what is important to see in this question is that you have the words like synthesizes or produces or transports. You have to ask yourself, is it directly and is it in the actual place? Let me show you an example because it's a bit hard for me to explain it like this. So synthesizes, what is synthesizes is to create something from zero, de novo. Amino acids. Does the rough ER synthesizes from zero create the amino acid? It isn't. Because amino acid, we are basically getting them from food or we make them in different metabolic pathways, but we don't synthesize them. We help to basically polymerize them. So when you have so many words like synthesizes, produces, transports, forms, you should really think, is it directly or indirectly? Who actually synthesize amino acids? If it's non-essential, we can basically pretty much synthesize it from different metabolic pathways. If it's essential, we must get it from food. In both cases, it's de novo or not, and it's talking about making the amino acids, not connecting them. Produces ribosomes. Who actually produces ribosomes? The rRNA or the nucleolus, basically. So I convinced myself this one is not correct because it is in the nucleolus. So it's not correct. Transports protein. What do I know about the RAF-ER? The RAF-ER takes the ribosomes, allow them to basically translate the polypeptide inside, make the vesicle, and transports it. So the RAF-ER is transporting proteins. But let's go to D. Make triglycerides and phospholipids. Who actually makes triglycerides and phospholipids inside a cell? The smooth, exactly. The Golgi mark, the Golgi is basically puts different chemical and molecules, different functional groups, phosphate, sulfate, and mainly carbohydrates in order to mark this molecule for different parts of the cell. A very, very good example to remember that when you create in the early stages of a red blood cell, an erythrocyte, you need to create the ABO blood system. The ABO blood system is basically antigen that you present on the plasma membrane of the cell, and the ABO are name of glycoproteins. They have a glyco inside the proteins, and this glyco part in the ABO blood system is being attached to the growing polypeptide in the Golgi. So in the early stages of the red blood cell, you will have the polypeptide basically getting this glyco part, becoming glycoprotein, which contains either the A or B glyco. And then it will be on the surface of the cell, mainly in order to show the body and to have antigens on top of the plasma membrane. It's in the mainly cellular signaling pathways. So I hope this question made sense when it comes to actually how to read this type of question, because they will give you a lot of questions that have many different things. For example, amino acids, ribosomes, protein, they are all indirectly or directly related to the RAF-ER. So it's really important to use the steps and to know exactly, to convince yourself why each one is correct or not. And of course, highlighting and noticing these type of words. Ask yourself, is it actually making it, or where do I actually get it from? So this one was important as well. I want to do one more question, which I believe it's very important and very probable to actually appear on the exam, which is the following question. Where can I find the WhatsApp group? I will send a link during the question. Perfect. I've sent the WhatsApp link to the chat so you can join. There are not many places in it. I think 2 more. So if there is not enough, just send me a message on Enter Med School and I will basically share it. Even on Enter Med School it's better. The latest post, you can just comment on it. Can you share the left questions with us as we don't have enough time? Of course. The PDF is on Enter Med School. Just go to my profile and to my posts. B, because we process according to cytoplasm. Exactly. So C, B. I want to go through the entire process of glucose metabolism because I believe it's really important, and sometimes many people find it a bit overwhelming because when you study biochemistry, they give you so many names of enzymes and ATP, and if it's endothermic or exothermic, it's really difficult. But for the IMAT exam, you should pretty much know a couple of very straightforward things. So let's start from the very, very basic, and I'm gonna ask you guys, is the process of transporting glucose inside the cell, let's say a liver cell which has enough glucose, has enough oxygen, is it an active transport or a passive transport? Active, okay. Active. Okay, so the process of transporting glucose inside the cell is passive. You have a molecule called the GLUT receptor, which is basically going through facilitated diffusion. Because glucose is a very big and polar molecule, it can't easily go through the plasma membrane, therefore we are going to have to create a channel for it. But because the concentration gradient is going to be from the outside to the inside, yeah, I know guys, the group is full, but just send me a message on WhatsApp, don't worry about it. Or send me a message on Enter Med School. Like the latest post, just follow it, it's better. Because we basically, the first thing we do to glucose when we put it inside a cell, yes, facilitated diffusion is a passive diffusion. We only help it to go through a specific channel, but the concentration gradient allows it to enter passively to the cell. Because what do we do to glucose as soon as glucose enters the cell, which is extremely important to remember? We are going to take a phosphate and we are going to assign it to glucose, and now we are going to get something called glucose 6-phosphate. The point is that glucose 6-phosphate is a completely different molecule than glucose. Therefore, because you pretty much don't have glucose inside the cell, the concentration gradient is going to be from the outside to the inside. Now, once we have glucose inside the cell, we are going to go through glycolysis. Do you guys remember how many ATP, NADH, and pyruvate do we actually get from glycolysis? Isn't it secondary act of transport? It really depends. You have some mechanism that can allow you to enter glucose inside a specific, for example, part of the proximal tubule of the nephron. Through the sodium enters, glucose leaves. But in general, in liver and in general cells, it's a passive mechanism. Exactly. So you are going to have 2 pyruvate, 2 NADH, and 2 ATP total net from this reaction. Because we are basically spending 2, one to phosphorylate the glucose and the second one in the pathway, and we basically get in form. So a net of 2 ATP. What is going to happen to this pyruvate molecule when we have enough oxygen inside the cell and we want to use it to more energy? So pyruvate is going to go and enter the mitochondria. But what happens between the Krebs cycle inside the mitochondria and the glycolysis itself? Do you remember? Link reaction. Exactly, acetyl-CoA. So the link reaction are basically a set of enzymes called pyruvate dehydrogenase on the surface of the inner membrane of the mitochondria. And what is going to happen basically, we are going to have 2 very important steps. One, the oxidation of pyruvate, which is we are getting another NADH because we took proton from the pyruvate. The second one is the decarboxylation of pyruvate. Decarboxylation is the taking of carbon dioxide outside of the pyruvate, removing carbon, and then we get a 2-carbon molecule because pyruvate is a 3-carbon molecule. Now we are going to have something called acetate, which is a 2-carbon molecule. We are going to add it CoA, which is a molecule you don't really need to know the structure of, and we are going to get acetyl-CoA. Acetyl-CoA is a 2-carbon molecule connected with CoA, and it's going to go into the Krebs cycle inside the matrix of the mitochondria. How many NADH, FADH2, ATP and carbon dioxide do you get for each acetyl-CoA that's going inside the Krebs cycle? Let's see. Many. Okay, so we are going to have for each acetyl-CoA, we are going to have 3 NADH, 1 FADH2, 2 carbon dioxide, because we are basically going to decarboxylate this molecule twice in the Krebs cycle, and 1 ATP. For each acetyl-CoA. This is going to occur twice for each glucose molecule, because you have 2 pyruvate, therefore 2 acetyl-CoA for 1 glucose molecule, which is really important. So 2 NADH, 1 FADH2, 2 carbon dioxide, and 1 ATP times 2 exactly for 1 glucose. Why do we need the electron carriers? Why do we need NADH? Why do we need FADH2? What do we use it for inside the mitochondria? We use it for the electron transport chain. So the electron transport chain is a sequence of 4 proteins with extra 1 on the surface of the mitochondria, the inner membrane, and it's basically going to allow us to take the protons we took along these different metabolic pathways using NADH and FADH2 and use them to yield energy for the protons. So we are going to have 1, 2, 3, 4 proteins, and then in the next we are going to have one big molecule that's called ATP synthase. So we have complex 1, complex 2, complex 3, and complex 4. We also have different proteins inside and coenzymes along this electron transport chain, but I never saw questions that actually ask specifically on it, so let's assume we only have these 4 proteins. The idea is that NADH, which is basically an extra 2 electrons that it is carrying, is going to donate 2 electrons to complex number 1. And it's going to become NAD plus again. It's going to go through oxidation. Then FADH2 is going to also arrive, and it's also going to bring 2 electrons to this site and to oxidize into FAD plus. What happens? Electrons have a lot of potential energy. And when the electrons basically, in a very simple word, jump between the protons, so it will jump here and here and here all the way to 4, they release energy. And molecules complex number 1, 3, and 4 are going to take this energy and to yield this energy into pumping motion that's basically going to take protons from the inside of the matrix to the inner membrane space against the concentration gradient. Therefore, it's an active transport of proton. This is why we need the electrons. What's going to happen? We are going to have a very, very high concentration of protons in the inner membrane space, in basically comparing to the matrix itself. And what do we know when we have a lot of protons in an area? What happens to the actual pH and what happens to the electrical charge of this area? Because protons are positively charged, we are going to have a lot of positive charge in the inner membrane space. And because protons are directly associated to the acidity of the area, because the pH scale is the molarity, the concentration of the protons you have, you're going to have a very low pH comparing to the matrix. The combination of the positive charge and the combination of the low pH is going to give us a gradient that's called electro for the positive charge, chemical for the pH, gradient. So basically the protons will want to go back to the matrix in order to reach equilibrium once again through basically physical thermodynamic, basically. They want to reach equilibrium and they want to go back to the matrix to reach basically stable state. The thing is that the only place they can actually move through in order to go back to the matrix is through one enzyme called ATP synthase. ATP synthase is basically a gate for protons, and the protons will want to go back to the matrix, and they will only do it through these enzymes called ATP synthase. And they will do it by a lot. Thousands and thousands of protons per second are going to pass through this ATP synthase, and so many are going to pass, they are basically going to it's like a kinetic motion, a motor motion. And this ATP synthase, it actually looks like a motor. And because so many protons are moving through this ATP synthase, you're going to have this circular motion, this basically kinetic energy. This kinetic energy is going to be yielded to take ADP, which is a used ATP, and a free phosphate, and through anabolic endothermic process, because you need to invest energy, create and recycle ATP once again. And this process is extremely important, and basically it yields the most amount of ATP through the entire metabolic pathway. So if I will sum it up, glucose enters the cell, goes through glycolysis. It yields a very small number of ATP. Then it goes through the link reaction, which connects the Krebs and the cytoplasm, the glycolysis, to the matrix, to the Krebs cycle, and we get very small number of NADH and some waste product, which is carbon dioxide. Then this acetyl-CoA, which is a molecule we got from glucose, it's going to enter the matrix, and we are basically going to break it down even further and get again very small number of ATP. In total, we got really small number of ATP comparing to the electron transport chain. Now we are going to use the electron transport chain in order to actually yield the vast majority of ATP, because electrons have a lot of potential energy we can actually use. The last and most important thing to remember is the reason that this electron transport chain is called aerobic respiration. It is because in complex number 4, we have oxygen waiting, just sitting there and waiting. Oxygen basically is going to accept the electrons that are jumping from 1, 2, 3, and 4 all the way to oxygen. And this is one of the most rare places we have in nature that oxygen go through reduction. We are basically going to reduce oxygen, we are going to give it electrons and to make water, H2O. And remember, for reduction and oxidation, there is the inorganic and organic definitions. The organic one is basically the addition of oxygen is oxidation, and the removal of oxygen or the addition of hydrogen atoms is reduction, and vice versa. And inorganic, basically it's the addition of electrons to the molecules is reduction, and the taking out of electrons from the molecule is oxidation. And as you can see here, basically the protons are hydrogens, but we also give them electrons with the protons. Therefore, we reduce oxygen and we cause it to become water at the end. And this is why we basically need oxygen at the end. This is basically everything you need to know for the IMAT exam when it comes to the aerobic respiration. Let's go through quickly what happens when you don't actually have oxygen inside a muscle cell working muscle cell that doesn't have enough oxygen to work, and a yeast cell. How much ATP do we gain from NAD and FADH2 molecule? Okay. According to Cambridge, and I will explain the idea itself and the concept, one NADH molecule is going to yield 2.5 ATP each on average, and one FADH is going to yield 1.5 ATP. Even though, and it's a bit weird, both of them are going to donate 2 electrons. So why do we get less ATP from FADH? It is because NADH is basically going to donate the electrons to this first complex, and FADH2 is going to donate electrons to the second complex, and because the distance between the first and the last one is bigger than the distance from the second one to the fourth one, you get less potential energy out of the jumping electrons, therefore less ATP per molecule. The number of water molecule from NADH and FADH2, 1 water molecule and 2.5 ATP each. You need to think about it because how many electrons do you need to reduce oxygen? You need 4 electrons. But oxygen, if you see in books, basically oxygen is not in the diatomic version, it's in the half version. It's basically half O2, which is basically O. So this O needs to get 2 electrons, therefore it will create 1 water molecule. But because it's actually O2, we are going to have 4 electrons, and therefore we are going to have from 1 O2 2 water molecule, 1 for NADH, the second one for FADH2. It's a bit too complicated for the IMAT, so even if you didn't get it 100%, it's really fine. Just remember the general concept and why do we even need so many electrons in order to use it in the electron transport chain. Protein number 2 has the highest energy. It's not, you mean the complex itself. You need to remember that the complexes, only 1, 3, and 4 can actually pumps protons outside. NADH is going to allow us to pump 10 protons outside based on the fact that it's basically bigger distance from the complex number 4. And FADH is going to allow us to pump 6 because complex number 2 can't pump anything. It needs only 3 and 4. So this is pretty much it for the exam. Beyond it, it's a bit too much. It might be a bit confusing a few days before the exam. Let's talk about what happens to pyruvate when we actually don't have oxygen. So when we don't have oxygen, inside the liver cell or muscle cell that works very hard, we are going to have something called lactic fermentation. We are going to cause pyruvate to become lactic acid. What is the difference on the molecular level between pyruvate and lactic acid? Lactic acid is pyruvate with 1 proton extra. Where do we get this extra proton? We basically get it from NADH, which becomes NAD+. The idea of fermentation is that in order to keep the cell alive, we always need to have glycolysis working all the time. And in order to keep glycolysis working all the time, we must have available NAD+ all the time because it's basically something we need to use in order to basically keep the glycolysis working. Without this one molecule, we won't have glycolysis. So we need to find some other ways other than using oxygen to actually recycle NADH back to NAD+. We do it through fermentation. So in muscle cells that work and don't have enough oxygen, we have the formation of lactic acid. But in yeast cell, for example, we have something called alcoholic fermentation. Alcoholic fermentation, we do have the oxidation of NADH back to NAD+, of course, because this is why we do fermentation, but we also have an extra step called, as you remember, decarboxylation. So we also add carbon dioxide. And we are going to get from alcoholic fermentation ethanol, which is alcohol. And we see it in beer, for example, beer fermentation. We are going to have carbon dioxide and alcohol when the yeast actually forms the beer itself. It's irreversible because you lose carbon dioxide. However, this reaction is reversible because lactic acid adds 3 carbon, and in the liver, through a specific enzyme, you can take lactic acid and make pyruvate acid or pyruvate once again. That's it. I really hope I was able to help you guys. It's really important to me to really reach and help as many people as I can. And I hope I was able to give you some tips on how to look on the questions and how to solve them, some strategies. If you have any question, let me know. Of course, guys, of course. I'm really working extremely hard, and the team as well, to really reach and help as many people as we can. Last year we had 2 volunteers. This year we are close to 45 volunteers, and if you guys really want to help us out and join next year, for example, we are looking for ambassadors for specific universities in Italy that will be able to guide specific students who want to, for example, go to Bologna or Pavia or Rome. Just let me know after the IMAT and let me know. This way we can really reach a lot of people and help a lot. No problem, guys. The next conference will cover other topics. The next one will be pretty much the same, but I will maybe show with different questions. Thank you so much. Can you please send the PDF here and also make video for general knowledge? For general knowledge, it's pretty much the Anki deck, and to understand that some questions you can solve with logic. You should check the latest simulator on Internet School because I had a bit of a summary on it. And also you guys, you should really check the work solutions. Can we join the next conference? You should join, but if we hit 99 people won't be able to join. Can you add a video about the latest topic, cellular respiration? I'm going to cut this entire recording and I'm going to upload it to YouTube right now, so you will be able to watch it. Alright everyone, best of luck, and if you have any question, feel free, just send me a message, email, or on the Internet School website, and I will see you in Italy next year. Bye everyone, have a good night.